All right, guys, we have a type of rule that we're going to start with. It's called recursive. Recursive rules are used a lot in programming. Computers love recursive rules. Okay, so the way that this is going to look, we're going to have a rule that looks kind of like this. There's going to be an a sub 1 with an equal sign and then a comma. Whatever it says a sub 1 is, that's going to be your first term, which kind of makes sense from what we talked about yesterday. Okay, a sub 1 is the first term, term 1, of an arithmetic sequence. Okay? Then it's telling you the rule to find more terms. It's saying the next term in the arithmetic sequence is, you take the previous term and you add the common difference. You guys see the little d for the common difference? Oh my gosh. Okay, so let's practice really quick on this one. We'll do a couple terms, maybe couple 5, so you get the idea. What is the first term of this example sequence? 10. Okay, how does the rule say to find the next term? I take the previous term and add 2. So I'm going to add 2 and I get 12. And then I'm going to add 2 again and I get
14.
And then I add 2 again and I get, and I can keep going and going until, I mean, I could keep going forever if it's infinite. Easy enough? Okay. So each time our common difference is added to the previous term to get our next term. Okay, we also learned yesterday about geometric sequences. So of course we're going to have a geometric rule. G sub 1 is going to be the first term of a geometric sequence. Okay. Then the rule says find the next term in the geometric sequence by multiplying the common ratio r with the previous term. Okay, so this one starts out, what's the first term? 5. What is my common ratio that I have to multiply the 5 with to get my next term? 3. So 5 times 3 is 15. You guys know what 15 times 3 is?
45.
It is 45. Oops, I wrote 4 because I was thinking about 45. Yep, 135. And then times 3 again. What is it? 405. Okay, and obviously we could just keep going until they tell us to stop. That's it. Easy. Okay, so each time our previous term is going to be multiplied by our common ratio. Okay, our common ratio is this r. It was this 3. All right, and that will give us our next term, time after time. So recursive rules are special because they require you to have a previous term to build off of. Okay, they're always defined in terms of a previous term. All right, so all we have to do for these is write the first 4 terms of each sequence defined by these recursive rules. So it just says the first 4. So I'm going to get my little spots ready. I want 1, 2, 3, 4, and then I'm going to be done. Separate them with commas, please. What is my first term according to the rule? Correct. Okay, what do I have to add to my -3 to get my next term? Correct. So my second term is 1. My third term is, fourth term. Don't you love today? You're tired. All right, now this one I can tell is going to be geometric because it's got a whole bunch of G's in it. Okay, plus it looks a little bit different. I can see the recursive rule has adding in it. And the, I said recursive, they're both recursive. I said the arithmetic one has adding, and then the geometric one has multiplying. All right, what is my first term in this cute little geometric sequence?
2.
2. Okay, what am I multiplying by to get my next term?
3.
3. So it'll be multiplying by 3 every time. So my, yep, 6, and then 18, 54. Okay, that's not bad. Okay, so, guys, my first term is a sub 1, right? What do you think my fourth term would be called? A sub 4. Okay, so I need the other 3 with a recursive rule because each term is defined by the ones that came before it. Okay, so I have to find all 4 of them to find the fourth one. But the only one I really am going to say is my answer is the fourth. Okay, so I'm going to get ready with my a sub 4 equals, and I'm going to have my little answer box. And then over here, I'm going to look for my G sub 4. My answer box. Okay. What is the first term in this rule? 14. What's my next one? How did you get that? Subtract 2. Good. What's next? Okay. 8. Now, does it say that it wants all 4 as my answer? No. Which one does it want? The 8. So basically, it's the same kind of process for the problem, but on this one, it's the whole list of 4 that's the answer, and on this one, it's just the fourth term that's the answer. Does that make sense to everybody? Okay. All right, this one says start at 9 and then do what? Multiply by a third. So what is 1/3 of 9? Correct. And then 1/3 of 3? 1. And then 1/3 of 1? 0.3 repeating, can I have that as a fraction? It's just 1/3. Yeah, 1/3 of 1 is 1/3. Okay, so that goes in my answer box. Yeah, okay, so hit the math button. What? That
Oh,
doesn't
you have
sound
to
right.
go into the box and then
All right,
press fraction.
so if you do 1 divided by 3, I'm getting this, right? And then I hit the math button. What do I want to turn my decimal into? A fraction. So which one am I going to pick from the menu? 1. Okay, so now I've selected the command from the menu. I haven't issued the command to the calculator. What button do I still have to push? Enter. Easy as pie. All right. All right, now we have to do something kind of fun. We have to find n. What is n? You remember from yesterday? check back, see if you labeled it.
Oh, I know. And with, how many different...
No. No. Did you label it on your tables? Term what? What word starts with N? Number. It's the term number. Sorry, I didn't hear you. Okay, so this is N. Okay, this is going to be our term number. You know how we had tables yesterday? We're going to make our own table. They didn't give us room to go vertically, so we'll just go long ways. Okay? Then this will be, it's arithmetic, so this will be our A sub n, which is our term. Okay, so what is our first term?
28.
28. So what is the n for 28?
2. 2. 1.
1. It's term 1. So its number n is 1. Okay, so what is it telling us to do? No, look at the directions. Find what? Okay, so are they asking us to find a term or find its number? Its number. Okay, so I want you to use the same strategies we did up here, but you're going to have to count the terms in the number row. Okay? I want you to try it. See if you can figure it out. Okay, so if I'm stopping at 18, then I'm going to 26 to 24, 22, 20, and then 18. I just have to figure out the n for that term. Yeah, 6. Okay, so now I have to answer the question. It says find n, so I have to say n equals 6. That's my answer. Okay? All right, I want you to try number 4. This one's geometric. Be careful. Okay, so my first term in this rule is 2, and then I'm multiplying by what every time?
3.
Okay, so I get 6, and then
18.
and then
54.
and then
62.
okay. Oh, that's it. That's the one I want. So which term is that?
5. N equals 5.
Okay. Good. All right, flip. All right, guys, we still have a whole page left to do, in spite of the fact that some of us are turning into werewolves in the back. Okay, so I want you to look at this and see if you can match the sequence up to his rule. They all start with 8. Okay. You want to look and see if you can find the pattern. Like, what is the pattern for this one? Is it subtracting 4 every time? What is it doing?
Dividing by 2.
Okay, so dividing by 2, we have to turn that into multiplication. What is dividing by 2?
Times negative.
It's not times negative 2. Okay. We're changing it into multiplying by a half. So you got to figure out what the rule is, and then match it up to its little,
And what do we put on the line?
the letter. You're just matching. Oh, so we said the first one was C. Okay. The next one is subtracting what? Subtracting 2. Which one of these says to subtract 2 every time? D. Okay, what's happening on the next one? Adding 2. Which one says to add 2? Hey. Okay, what's happening on the last one? Multiplying by 2. So that one is B. All right, let's look at Daffy's work. So Daffy Duck tried to classify and write some recursive rules for his sequences, but he made a bunch of mistakes. We're going to explain and correct the mistakes. So he's writing the rule. So this is what's given to him, and this is his work. He even put his name on it. Okay? He says that this rule is arithmetic. Is he right? Okay. Okay, he says the first term is, what did he say the first term is? What is the actual first term? 2. So what did he mess up in his rule? He mixed up what and what?
He mixed the terms.
What terms? Okay, what is it starting at? Okay. So the first term isn't 3, it's 2. What's happening every time?
It's going up by 3.
What does he say it's adding? 2.
Equals
Okay, so Daffy switched the first term and what's being added every time? What's the letter for that, the variable? No, it's not n. What gets added every time? The common? Which is d. Okay, so let's fix it. So we're going to follow his formatting, but we're going to just swap these two. Okay, so make sure that you write your subscripts small and neat. All right, so a sub 1 equals, no, 2. Okay. Then we find the other terms, a sub n, by taking the previous term, a sub n minus 1, and adding how much?
3.
3. Okay. All right, let's look at this one. What do you guys think?
It's adding on top, but for it shows geometric, which is multiplying.
Okay, so he said it was geometric, but it's not. Okay, so it's not geometric, it's arithmetic. All right, so we'll say that it's arithmetic. Okay. So how would you describe this mistake? He wrote
The wrong
kind of rule. Yeah. Daffy wrote a geometric rule for an arithmetic sequence. Okay, so this is an important lesson because his rule appears to work for the first 2 terms. Like, is the first term 6? Yes. Do you multiply by 2 to get the 12? Yes. But does that continue to work for the rest of the sequence? No, so you got to be careful because I'm sneaky. All right, so the correct rule, if we look back at our other arithmetic sequence that we wrote and use that as a model, we'll say a sub 1 is
equals to 6.
equals 6, comma, a sub n minus 1 equals, whoops, nope, a sub n, sorry, equals a sub n minus 1 plus 2. Okay. So, let's see if we can do the ones at the bottom real quick. All right, for A, what sequence type do we have?
3.
Arithmetic. Okay, so I'm hearing that we're adding 3 every time. Okay, so the 3 is the D. And what is A sub 1? Okay, so that's the 2 things that we need. We need to know what the first term is to get started, and then we need to know what to add every time. So we say A sub 1 equals 4, comma, A sub n equals A sub n minus 1 plus what? Plus how much? 3. Okay. I thought I heard 4 and 2. All right. What do you guys think about this next one?
Geometric.
It is geometric. How can you tell?
Because it's multiplying by 6.
Okay, it is multiplying by 6 every time. All right, so this one's a little bit different. We haven't had to write a geometric one yet. You can use the example up there. You can use the examples up there on the matching as models. So it says G sub 1 equals, what's our first term? 1. G sub n equals, okay, so we need the R times, okay, that's the R, 6 times G, okay, I am going to come around and I want you to do the last 2, and I'm going to deputize you as soon as you got them right. Okay. Okay, this one is arithmetic. Okay, the rule is A sub 1 equals 27. Hey guys, can you be quiet? I'm finishing up this video. Please be quiet. Thank you. A sub n equals A sub n minus 1 minus 0.5. Okay, this one is geometric. Please be quiet, I'm finishing my video. Thank you. All right, and G sub 1 is, you guys can help me if you want. What's G sub 1? 256. Whoops. And then G sub n equals, what's the common ratio? 1/4, very good. Times G sub n minus 1. We picked 1/4 because we saw that it was dividing by 4, but that we had to turn it into multiplication, which is multiplying by its reciprocal 1/4.